In this video, we will be covering Form 5, Chapter 1, Variation. This is a Part 2 video. For those who have not seen the first video, I would highly recommend you to take a look at that first because we will be continuing from there. For those who are new here, welcome. And for those who are coming back, welcome back to my YouTube channel. I'm Rishi, and without any further ado, let's continue. So in the previous video, we took a look at the symbol, the forms, and two of the variation concepts, which are direct and joint. In this video, we will be covering inverse and combined. Before going any further, let's take a quick recap to refresh your memory. So this symbol right here is known as the proportion symbol. And there are two forms, variation form and equation form. So in variation form, it's where we use this symbol right here to represent the relationship between two quantities. For example, A varies directly as B. And for equation form is where the proportion symbol becomes equals to K. So A equals to K times B. This K is what we later in this video I will be discussing what K actually means. So variation concepts, we covered two in the previous video. Direct, which means when one quantity increases, the other quantity also increases. And for joint variation is where we have multiple quantities that increase when A increases. For example, when A increases, the quantity B, C, and D, all of them increase in accordance to A. So joint variation is just the extended form of direct variation. Now that the recap is done, let's jump right into inverse variation. Inverse variation. By definition, inverse refers to something being in the opposite state or the reverse. Inverse is more like the reverse. To give an example, direct variation is when a quantity increases, the other quantity also increases. For inverse variation, it's the exact opposite. When A increases, B will decrease. This is how inverse and direct variation differ. For inverse, when A increases, B decreases. That's the whole concept. To represent this in a variation form, we use the same symbol, the proportion symbol, but now instead of writing it as B, what we do is we change it to 1 over B. A is directly proportional to 1 over B, or A varies directly as 1 over B. So you might wonder, why did I use this varies indirectly instead of using inverse? That's because this symbol still means directly proportional. It's just that to represent B is decreasing, we have used this 1 over symbol, which is known as reciprocal. It's a property in fraction. So we have used this to represent that B is decreasing. So we use 1 over B. So if you would like to write it as B instead of 1 over B, what you would do is you would write A varies inversely as B. Do not worry, your examinations will not ask you to explain this in detail. It's important that you understand the gist of it so that you know how to calculate using this concept. But in examinations, most of the times you would be asked to just write down, just state the form, either in variation form or in equation form. Now that we are done with the variation form, let's take a look at the equation form. So the same example, A varies inversely to B, which is now it's 1 over B. So this is the variation form. So the same concept applies here. The proportion symbol becomes equals K. So A goes right over here and 1 over B. So since they're beside each other, it's a multiplication relation. So for those who are curious, yes, you can write it as K over B. It means the exact same thing. That's all for the conceptual part. So now that we have a clear understanding of what inverse variation is, let's take a look at combined variation. As the name suggests, combined variation is where we combine direct variation, joint variation, and also inverse variation together. Given a question, for example, when when x increases, when x increases, y square decreases, z cube increases, and a the square root of a decreases. So most of your questions will be something like this. So as you can see, I have added few operators here like square, cube, square root. Do not be frightened by them. Do not be intimidated. All of those symbols do not mean much when it comes to writing down the variation forms and the equation forms. They're just there for you when you are calculating using them. Let's not worry about calculating now. So how you would write this is the same thing. So for variation form, you write it as x proportion, a proportion symbol. Now, let's categorize what are increasing and what are decreasing. So whatever that is increasing will go on top of the fraction as the numerator, and whatever that is decreasing will go down the fraction as denominators. So what is increasing? When x increases, z cube is increasing. So we will write z cube on top. And then, as we can see, y and a are decreasing. So y squared will go to the bottom, y squared. Then the square root of a will go right beside it. If you're wondering, this is a multiplication relation. That's it. Y is directly proportional to z cubed over y squared square root of a. So for those who are wondering, this symbol can be called as varies directly or directly proportional. These both mean the exact same thing. There is no difference. For those who are wondering, just a clarification. So if you would write it in the form of equation, it's not a biggie. What we have to do is just add in the k. The proportion symbol becomes equals k, and the whole term here will be put in a bracket because it's a multiplication relation. Z cube over y squared squared a. It's the exact same thing. There's no difference when it comes to changing the variation form into equation form. So that's what we have for combined variation. Now, let's discuss about k. What is k? In the previous video, I mentioned that it is known as constant, but I did not go in detail to what a constant is. So now let me explain. Constant is when a value is fixed, a fixed value. This value will not change. So let me give you the context in the form of an example. So when we talk about variation, we always say when x increases, y increases. Okay. So to contextualize it, in the previous video I talked about flour and eggs. So when mom uses one flour to bake a cake, let me go down a bit so that I have more room to work with. So when one flour is used, we will need 3 eggs. When two flour are used, two flour, not two flour, what am I saying? Two flour packets are used, we need 6 eggs. This is what we use, this is where we use the concept of ratio. So when we have 5 flour, what we do is we will need 15 eggs. Okay. So if we were to write this in the variation form, what we would do is we would categorize flour as X and we would categorize eggs as Y. So Y varies directly as Y. Did I say Y twice? Forgive me. X varies directly as Y. So here we say varies directly because when X increases, Y also increases. Okay. So here we have varies directly. So in the variation form, we will write it down as Y proportional symbol, X proportional symbol, Y. Now, when we write it down in equation form, we will have X equals KY. So to find K, we have to rearrange it. So K equals to X over Y. And since we have the values of X and Y, let's just try to substitute them. So X is 1 and Y is 3 in the first instance. So we have K equals to 1 over 3. So now when you write it down, you will get X is equivalent to 1 over 3Y. This particular condition, this particular equation is true for all the instances we have in relation to X and Y for this particular scenario. So the X and Y might change according to the values, but this 1 over 3 will not change. This is the constant for this particular scenario. In the previous video, I said that I will be doing some example questions in this video for better understanding. But due to time constraint, I will be uploading that in tomorrow's video. So be sure to stay tuned for that. And in that video, we will be covering a few exam type questions that you might encounter for your examinations. So till then, signing off, it's Rishi. Bye bye.